Welcome back. For this part, we're gonna go a little bit deeper than before. Now you know how to do mole to mole conversions. Now you know how to do grams to grams or mass to mass conversion. So now what we're gonna do with that? Now we're going to start using that information to start predicting how much our reaction can make and how much percent are we actually making. So what we are supposed to make using the mole to mole conversion, we're gonna call that what we are supposed, the maximum we're supposed to make in theory. We are going to call that the theoretical yield. So if everything goes right and your reactants is used 100%, the product that you're gonna make, that's what you're gonna make in theory. So that's the theoretical yield. If you go to the lab and you do a reaction, sometimes things happen. You have accidents, stuff like that, and you don't get to make as much as you were supposed to make. We call that the actual yield. And then, if you know the actual yield, which is how much you were supposed to make, and you divide that by the actual yield is actually how much you made, and you divide that by the theoretical yield, which is how much you were supposed to make, and you multiply by 100, you got your percent yield. But before you can do that, you have to be able to identify the limit and reactant. Whenever you have a reaction with two reactants to produce a product, the quantities that you have, one of them can be short. So the one that is short, the one that is going to be totally consumed before the other one is totally consumed, we call that the one that is going to limit you. That's going to be the limiting reactant. Similar to the example I gave you earlier, if you're doing a recipe where you need 2 eggs, for example, and you only have 1 egg, you're only going to be able to do half of the recipe. So it's going to limit you on how much you can make. So whenever we are trying to find the theoretical yield so that we can calculate the percent yield, the first thing you need to do is which reactant is limiting you. So let's learn how to find the limiting reactant. So let's say we have this balance equation as given, so assume that it's balanced. If I have 2 moles of this and 5 moles of this, which one will be the egg in the analogy I gave you? Which one is going to be short? Well, one way to do this is by every one of these, you're going to need twice as much of this. So you're going to need twice as much of B. So if you have 2 moles of A, you're going to need 4 moles of B. You're going to need twice as much. You have 5 moles, so you have more than enough. You only need 4, you have 5, so that one is on excess, which means A is going to be your limiting reactant. Let's do the next one. The next one, we're going to do it a little bit different. So there's several ways to find out the limiting reactant. One of them is comparing the proportion. For every one of these, you need twice as much of this and then see what you have. Another one is you can take, using the mole to mole conversion, you can take 1.8 moles of A and see how much product you can make. Then you can take 4 moles of B and see how much product you can make. The one that gives you the smallest amount is because it's limiting you. So that would be the limiting reactant. So let's see this. So we do not want the moles of A because we want the moles of C. And there's 3C for every 4A. So 3Cs for every 2A, sorry. For every 2As. So when we do that calculation, 5.4, 1.8 times 3 is 5.4. 5.4 divided by 2, that's going to be 2.7. So if you use 100% of A, which is 1.8 mole, you're going to make 2.7 moles of C. So what happens if we use the other product 100%? You don't want the moles of B because you want the moles of C, and there's 3 moles of C for every 4 moles of B. 4 times 3 is 12. 12 divided by 4 is 3. So as you can see, most of A is going to produce the smaller amount. So A is my limiting reactant. So this is going to equal my limiting reactant. What about the next one? The next one, we're going to do it also on a different way. We're going to take the 3 moles of A, and we're going to see how many moles of B I need to use. So I do not want the moles of A because I'm looking for the moles of B, and there's 4 moles of B for every moles of A. So that means I'm going to need 6 moles of B. I actually have 4, so I need 6. I only have 4, so this is my limiting reactant. So I just showed you 3 different ways to find the limiting reactant. So let's do the last one using the proportion. So if I have 22 of A, I'm going to need double. So from 2 it goes to 4. I'm going to need double of B. So I'm going to need 44 of B. I actually have only 40, so B is going to be short. And that will be my limiting reactant. So 3 different ways to find the limiting reactant. Use the one you like the best. And there's other way of doing it. So if you happen to know one of the other ways, by all means, fill whatever you feel more comfortable using. So with that said, you should be able to find out the limiting reactant on this reaction, given those 4 options. So you're going to have 4 different answers. So let's do another one. Determine the theoretical yield. So we found the limiting reactant. So once you find the limiting reactor, whatever amount of product you make with that, that's your theoretical yield. So step number 1, find the limiting reactant. And any calculation from there on has to be done with the one that is going to limit you only. So let's find the limiting reactant first. So if I have 1 mole of A, that means I'm going to need 2 moles of B. On this case, I have 1 and 1, so B is going to be short. Now that I know my limiting reactant, I'm going to use my limiting reactant to find my product, to see how much of the product I can make. I'm going to use the mole to mole ratio. And when I do that, there's 3 moles of C for every 2 moles of B. That means that if I consume all of my limiting reactant, the maximum I can make, if nothing goes wrong, in theory, is 1.5. So this is my theoretical yield. Let's do the next one. The next one, remember this is the reaction I'm using. So if I have 2 moles of A, I'm gonna need twice as much of B. So I'm gonna need 4B. If I have 2, I'm gonna need 4B. So I don't have 4B, I only have 2B, so that's my limiting reactant. So using my limiting reactants, 2 moles of B, I'm gonna see how much product I can make, which means I do not want moles of B because I'm looking for moles of C, and there's 3C for every 2B, which means I'm gonna make 3.0 moles, which is gonna be my theoretical yield. Once I find the limiting reactant, I'm gonna use my limiting reactant to calculate my product. That's assuming that nothing goes wrong on the lab, so that's in theory, so that's my theoretical yield. Let's do the next one. On the next one, I have 1 mole of A, which means I'm gonna need 2 moles of B, but I have 3, so I have more of what I need, which means A is my limiting reactant. A is the one that is gonna be short. So to find the theoretical yield, I'm gonna use my limiting reactant. I only have 1 mole of A, and I'm gonna find the moles of the product, and using conversion factors, there's 3 moles of C for every 1 mole of A, so 3.0 moles is my theoretical yield. And for the last one, once more, if I have 32 of these, I'm gonna need twice as much of B, so I'm gonna need 64. I have 68, so I have more than enough, so the other one has to be my limiting reactant. Once I find the limiting reactant, that's the only one I'm gonna use for my calculations, which is 3 moles of C for every 1 mole of A, which is gonna give me 96 moles of C. And this is my theoretical yield. So that's how you find the theoretical yield. Find first which reactant is the limiting reactant and use that one to calculate how much product you can get. So with that in mind, now you should be able to do this daily work. And once you're done with that, we're gonna go to the last part. We're gonna find the percent yield. Percent yield is nothing more than the actual over the theoretical yield. The actual yield over the theoretical yield multiplied by 100. So remember, actual yield is what you get when you go to the lab and do the reaction. It's what you're gonna produce, what you're actually gonna isolate, what you're actually gonna recover. Any word that implies this is what I got at the end. So for this particular problem, we have a balance equation. It says for the reaction, calculate the percent yield is 0.5 moles of titanium 4 chloride are recovered. So this is my actual yield. So my actual is what is being recovered at the end, which is 0.5 moles of titanium 4 chloride. So all I need to find is the theoretical yield, which you know how to find out, right? You have 5 moles of titanium, so you got 5 moles of this, and you're gonna need twice as much of the chlorine gas, so you're going to need 10, but you only have 9, so the chlorine gas is my limiting reactant. So using only my limiting reactant, which is 9 moles, so 9 moles of chlorine gas, I'm gonna find my product, which is the moles of titanium 4 chloride. So I'm gonna use my train track. I do not want the moles of chlorine gas because I'm looking for the moles of titanium 4 chloride, and that's gonna be 1 of the titanium 4 chloride for every 2 of the chlorine, which means I'm gonna get 5.5 of the product. So this is my theoretical yield. So 0.5 divided by 4.5 moles times 100 is gonna be how much? Just give me a second. So 0.5 0.5 divided by 4.5, 0.5 divided by 4.5 times 100 equals 11.1%. So this is your percent yield. So once more, if you are asked to find the percent yield, the formula is actual yield divided by theoretical yield multiplied by 100. And the actual yield will most likely be given on the problem, because it's going to tell you that it was recovered, isolated, produced, or something like that. So you already have the actual yield, so all you need is the theoretical yield, so you can do actual over theoretical. And the theoretical yield, for the theoretical yield, you're going to need to find the limiting reactant first. We find out that chlorine was the limiting reactant, so we use the amount given for chlorine to find how much of the product you can make by using the fact that for every 1 mole of product, you need 2 moles of chlorine gas. And that gave us 4.5. So not too difficult, but it can be confusing at first when you're learning it. So make sure you practice and send questions my way. There's also a lot of good tutorial videos posted in Canvas to understand this better. And with that in mind, you should be able to do this daily work now. You're looking for the percent yield. And with that, you know how to find out the limiting reactant. With the limiting reactant found, you can then find the theoretical yield. And if you're given the actual yield, then actual yield divided by theoretical yield, that should give you your percent yield. And we did that only with moles. So if we had to do it with grams, we just convert the grams to moles, which is what we're going to do on the next part. So when we come back, we're going to do exactly the same thing, find the limiting reactant, find the theoretical yield, find the percent yield, but we're going to begin and end with mass. So we're going to do it with grams. So see you soon.